Module 3. Today's lecture is a deep dive into Ethereum. It is important we understand Ethereum as it forms the basis of many of the developments in cryptocurrency that we will discuss later, hence why this is one of the more detailed modules in the course. Before you can understand Ethereum, it helps to first understand the internet. Today, our personal data, passwords and financial information are all largely stored on other people's computers, in clouds and servers owned by companies like Amazon, Facebook or Google. This setup has a number of conveniences, as these companies deploy teams of specialists to help store and secure this data and remove the costs that come with hosting and uptime. But with this convenience, there is also vulnerability. As we've learned, a hacker or a government can gain unwelcome access to your files without your knowledge, by influencing or attacking a third-party service, meaning they can steal, leak or change important information. Brian Behlendorf, the creator of the Apache web server, has gone so far as to label this centralized design the original sin of the internet. Some like Behlendorf argue the internet was always meant to be decentralized, and a splintered movement has sprung up around using new tools, including blockchain technology, to help achieve this goal. Ethereum is one of the newest technologies to join this movement. While Bitcoin aims to disrupt PayPal and online banking, Ethereum has the goal of using a blockchain to replace internet third parties, those that store data, transfer mortgages and keep track of complex financial instruments. In short, Ethereum wants to be a world computer that would decentralize, and some would argue, democratize, the existing client-server model. With Ethereum, servers and clouds are replaced by thousands of so-called nodes run by volunteers from across the globe, thus forming a world computer. The vision is that Ethereum would enable this same functionality to people anywhere around the world, enabling them to compete to offer services on top of this infrastructure. Scrolling through a typical app store, for example, you'll see a variety of colorful squares representing everything from banking to fitness to messaging apps. These apps rely on the company, or another third-party service, to store your credit card information, purchasing history and other personal data somewhere, generally in servers controlled by third parties. Your choice of apps is of course also governed by third parties, as Apple and Google maintain and curate, or in some cases, censor, the specific apps you're able to download. Take the example of an online document service like Evernote or Google Docs. Ethereum, if all goes according to plan, would return control of the data in these types of services to its owner and the creative rights to its author. The idea is that one entity will no longer have control over your notes and that no one could suddenly ban the app itself, temporarily taking all of your notebooks offline. Only the user can make changes, not any other entity. In theory, it combines the control that people had over their information in the past with the easy-to-access information that we're used to in the digital age. Each time you save edits, or add or delete notes, every node on the network makes the change. Let's say that Jamie requests $100 from you. This money is sent via your wallet through the distributed network into Jamie's wallet for his use. First, you need a place to securely store your Ether, or at least a place to store your private keys. This brings us to Ethereum wallets. One caveat is that losing your private key is a much bigger deal than misplacing a password. It means losing your Ether forever. Removing trusted parties is a two-edged sword. While intermediaries are no longer needed to verify transactions, there's no help desk to turn to for help recovering your secret key. With that in mind, there are plenty of options for wallets to store cryptocurrency: desktop wallets, web wallets, hardware wallets and paper wallets. Choosing one depends on your preferences for convenience and security. Usually, these two concepts are at odds with one another. The more convenient, the worse the security, and vice versa. Desktop wallets are run on your PC or laptop. One option is to download an Ethereum client, which is a copy of the entire Ethereum blockchain. There are a few Ethereum clients written in different programming languages and with different performance trade-offs. This process can take up to a couple of days, and will only increase as Ethereum grows. The wallet then needs to stay in sync with the latest transactions on the blockchain. Mobile wallets require fewer data to be downloaded to connect to the network and make transactions, so they are more suitable for download to a smartphone. The mobile wallet is more convenient, but not quite as safe. Full Ethereum clients offer a more secure way of receiving transactions because they do not need to trust miners or nodes to send them accurate information. They validate transactions themselves. Storing private keys on a device that is detached from the internet, a method known as cold storage, is harder to hack and is best used for storing large Ether holdings. However, the method is not as easy to use as when Ether is stored on a smartphone or internet-connected computer. Hardware wallets, which are often as small as a finger or two, arguably offer the best of both worlds. These secure devices that can often be detached from the internet and can sign transactions without being online. But again, this deposit box-like system is not a good option if you want to use Ether frequently or on the move. Another cold storage option is to print or carefully handwrite a private key on a slip of paper, a paper wallet, and lock it somewhere secure like a deposit box. Online tools can generate key pairs directly on your computer, not on a website's servers, which could leave keys vulnerable if the site is hacked. It's also possible to generate keys using the command line, provided you have the necessary cryptographic packages installed for your preferred language. All that said, again, if you lose your private key, it's gone for good. So, best practice is to spend some extra time creating multiple copies of the private key and stashing them in different secure locations, in case one is lost or destroyed. So how do you buy Ether? Buying Ether varies by country, or at least by currency. You need to find someone either online or in person who has Ether and wants to trade. There's always the option of meeting in person to buy or sell Ether, especially if living in a city with frequent Ethereum meetups, such as New York or Toronto. That's not always an option in less populated areas. Exchanges allow users to buy Ether directly with dollars or Bitcoin. Typically there is a sign-up process. Buying Ether with another currency might take an extra step. Bitcoin is the most commonly used cryptocurrency, and people around the world are more likely to want to trade for it in their currency. So, if you want to buy Ether for rubles, for instance, the easiest way might be to purchase Bitcoin at an exchange and then trade that for Ether. Once you have Ether, you can send it directly to another person, peer-to-peer. It will likely cost a small transaction fee paid to miners. Now what? You may have noticed that the wallet and exchange lingo up to this point has been quite similar to Bitcoin. But Ethereum applications are quite different. Users with Ether can join or create smart contracts, code that automatically executes the terms of an agreement so that you don't have to rely on a third party. Don't worry, we will look at this in more detail later. Bundles of smart contracts can be used to create decentralized applications dApps, which you can use or join. In the next lecture, we will look at Ethereum in more detail.